First key feature we're going to talk about with rational functions are vertical asymptotes. As stated in the previous video, what vertical asymptotes are, they're kind of like these imaginary vertical barriers, these vertical lines that your function approaches but never crosses. So you can see them in these first two examples. So although it kind of looks like over here that these functions might actually hit the vertical asymptote, it actually just gets closer and closer and closer as we approach that vertical asymptote, but it actually never touches it. Now in the third example, you don't see them because it's technically not part of the graph, but you can see that I can insert sort of these vertical lines at 2 and at -1, and our graphs approach those but never actually touch them. So when do these vertical asymptotes occur? Well, they occur when the inputs, what you're plugging in, is not in your domain. So you get a domain error. So essentially, with rational functions, that's going to happen when the denominator is 0. Since we're dealing with fractions here, if the denominator ends up being 0, we get a domain error, and most likely would result in a vertical asymptote. So to find them, we're just going to take the denominator and set the denominator equal to 0, and we're going to solve. So in this first example, we're given this, it's actually called a reciprocal function, which is a subset of rational functions. But if we want to find the vertical asymptote, we're going to take our denominator, which is x plus 1, set it equal to 0, and solve. So that's easily done by subtracting 1 on both sides. So you have a vertical asymptote at the line x equals 1. I usually just denote that with a VA for vertical asymptote. And what the graph would look like, something like this, where you see at -1, there would be this vertical asymptote that both this part of our function approaches it but never actually touches it. Same thing with this part of our function, approaches but never actually touches it. If we were to, say, zoom in here, you would still see space between our graph and our asymptote. Even though it looks like it's right on top of each other, there will still be a little bit of space. In this next example, it's a little bit more complicated. We're asked to identify the vertical asymptotes. So again, we're going to take our denominator, which is x squared minus 2x minus 8. And we're going to set this equal to 0 and solve. Now this is a quadratic equation, so we should know that solving quadratic equations, we would like to try and factor this if we can, which looks like this is easily factored to x minus 4x plus 2. So then, remember, we can use the zero product property by taking x minus 4, setting it equal to 0, and x plus 2, setting it equal to 0. So we end up getting vertical asymptotes at 4 and at -2. And our graph would look something like this. So what you see in red is the actual function. What I have in blue are the vertical asymptotes. Again, you can see we have it at x equals -2 and at x equals 4. So that's how you find vertical asymptotes. When it comes to actually graphing these, again, you guys can use a graphing calculator or just make an XY table to get a general sketch. Because we're learning remotely, it's kind of tough for everyone to be able to graph these if you don't have a graphing calculator. So that's why we're concentrating on these key features. But you can always use Desmos or any of your online resources if you need to graph these as well.